In this module, we learn about perimeter and area of polygons and different compound figures. What is a polygon? A polygon is a closed figure having three or more sides joined by line segments. Polygon comes from Greek words poly, which means many, and gon, which means angle. Now, classification of polygons. Polygons are classified as regular and irregular polygons. Regular polygons are those which have all sides as well as angles of equal measure, whereas irregular polygons do not have sides and angles of equal measure. Examples of regular polygons are square, equilateral triangle, regular hexagon, etc. Examples of irregular polygons are rectangle, rhombus, trapezium, etc. Now we learn how to find perimeter and area of compound figures and polygons. To recall, let us state some formulae which we have already discussed in the earlier classes. Before moving ahead, let us read some units of measurement. What is a compound figure? A figure that is made by combining triangles, polygons, semicircles and other two-dimensional figures is called a compound figure. Perimeter of a compound figure. It is the distance around a compound figure. The given figure is a combination of a semicircle, a rectangle and a triangle. Therefore, perimeter is equal to AB plus BC plus CD plus DE plus circumference of semicircle. The circumference of semicircle is found using the formulas C is equal to pi r or C is equal to half into pi d. So, we get the value of circumference as 4.71 centimeter. Therefore, the perimeter of the given compound figure is equal to 7 centimeter plus 5 centimeter plus 4 centimeter plus 7 centimeter plus 4.71 centimeter. That is equal to 27.71 centimeter. The area of a compound figure can be found by adding or subtracting the areas of the simpler figures that compose the compound figure. So, let's take an example. Joe has to mow the lawn of the field below. How many square centimeters must he mow? Since the field is composed of a semicircle, a rectangle and a triangle, therefore total area of the field is equal to area of semicircle plus area of rectangle plus area of triangle, that is half into pi into r square plus L into B plus half into B into H. Putting the values in the given formula, we'll get the area of the field as 122.13 square centimeters. So, Joe must mow 122.13 square centimeters of the field. Let's take another example. Detective Laurie must investigate a crime committed at the local park. How many square meters of ground must he cover when looking for the clues? To find the required area of ground, let's follow these steps. Step 1. Find area of big rectangle, risk. Step 2. Find area of smaller rectangle, lawn. Step 3. Subtract the smaller area from the larger area. Putting the values of length and breadth in the two rectangles, we'll get area of big rectangle equal to 77 meters square and area of smaller rectangle equal to 12 meters square. Therefore, the area of the ground is equal to 77 meters square minus 12 meters square, that is equal to 65 meters square. Now, Detective Lorry must isolate the crime scene. How much tape will he need? For finding the length of the required tape, Detective Lorry must find the perimeter of the ground. Perimeter of the ground is equal to sum of its sides. Putting the values of the sides, we'll get the perimeter as 42 meters. So, Detective Lorry needs 42 meters of crime scene tape. Let's take an example of a complex figure. A surveyor copied the shape and dimensions of a field as shown below. Find the area of the field. As the given field is a combination of triangle AXE, trapezium EXZD, triangle CZD and triangle ABC, therefore required area is equal to area of triangle AXE plus area of trapezium EXZD plus area of triangle CZD plus area of triangle ABC. Area of triangle AXE is equal to half into B into H, that is equal to half into AX into EX. Putting the values, we'll get the area of triangle AXE as 5874 meter square. Area of trapezium EXZD is equal to half into sum of parallel sides into height, that is equal to half into sum of EX and DZ into XZ. Putting the values, we'll get the area of trapezium EXZD as 30,240 meter square. Now, area of triangle CZD is equal to half into B into H, that is equal to half into ZC into DZ. Putting the values, we'll get the area of triangle CZD as 9,360 meter square and area of triangle ABC is equal to half into B into H is equal to half into AC into BY. Putting the values, we'll get the area of triangle ABC as 15,922 meter square. Adding equation 1 to 4, we'll get area of the field as 61,396 meter square. Let us recall. In this module, we have learned about polygons, compound figures, important 2D formulae, and finding perimeter and area of polygons and different compound figures.